And this prompt, do nothing else, press play. Welcome back to Fairyland. Here we have the inverse sine of 1/2 equals what? And you think, I have no idea. And I agree. Except that I don't agree. Because you've already done this problem. It just didn't have the inverse sign before. Those mean the same thing. Almost. Meaning, this is saying I have some input that back in the day of the original function was an output. What? Yeah, because the domain and the range switch. That's why the x and the y switch when we solve for inverses. That's right. Yeah, that happens. So it's some value, and I need to find this thing. Look at that. Look at all this I'm giving you. That's an angle. We've got to find an angle that makes that true. So find it. You can just look at your notes, literally from the last video. It's right there. We're 5 pi over 6 and pi over 6. I'm not going to write the solution out yet, though. We're going to copy 3 things down. In fact, you should just graph sine, cosine, and tangent on your own, because you can do that. So do that. Make it like sine, cosine, tangent. We'll talk about it. Tangent, which you should have already graphed. And we're talking about this idea of inverses. These are not inverses, but we need to use the graphs because the inverse comes from each of these functions. We're talking about inverse sine, inverse cosine, inverse tangent. So, look, no. How do we find them graphically? How do we know if something's invertible? No, not the vertical line test. Not the vertical line test. No, something like it. Yeah, that's the only other thing that's like it. We use the horizontal line test. And as soon as we do that, we see, oh hell, it doesn't pass the horizontal line test. In fact, none of these do. Which means that they're not invertible. So why are we talking about inverses? Well, because they are invertible on a certain interval. So find an interval that these are invertible on. Oh, let's see. What should it include? Well, all of the y values, right? The range. So all y values. And can't repeat, or it becomes invertible and fails the horizontal line test. So find that. Yeah, I figured you hadn't found it, but you should probably pause it and try it first. Just have a go at it. All right, fine. So here we are. Look, if I start at the minimum and go to the maximum, I have repeated no values, and I've included all of my range. And so that section right there, a negative pi over 2 to pi over 2, is in fact invertible. Yay. Find similar sections on those other 2 functions. Also take note that if I label that negative pi over 2, which it is, on the unit circle, I'm talking about the right half of the unit circle for sine of x. So go ahead and do this pattern likewise for the rest. So there were plenty of acceptable values here, but I went with the standard conventions. You should add these to whatever solutions you came up with. The standard conventions are what we use every single time to find the inverses. Okay, finish writing this down, then unpause the video. Okay, you finished writing it down. Let's go back to this problem. Sine of inverse of 1/2 is an angle. Notice before we had 2 solutions. What are we allowed to pick from? Just the right half of the unit circle. So which of those solutions is in the right half? That's right, just one of them. So I've got to choose this one. So that, when we're talking about the inverse function, there's only one solution here, because it's a one-to-one function, so that's what we choose. Together, But try them on your own seriously. B is the most straightforward, TBH. Sine of a -1. Where is the -1? Well, it's right there on the bottom of the unit circle. What angle is that? And you're going to tell me that it's 3 pi over 2, because that is what it is when you go this direction. But guess what? That's a negative pi over 2. And this interval says a negative pi over 2 to pi over 2. Is 3 pi over 2 in that interval? The answer is no. So I need to get more comfortable with my negatives. So what is this actually? Well, that angle actually is a negative pi over 2. So my solution here is a negative pi over 2. We'll practice that, so don't freak out. But the concept is the same. Where's cosine a negative square root of 2 over 2? Right, I got to pick from this side. There's plenty of times. It's here and it's here, but we can only pick from the top half, so we pick from the top half. What angle is that? It's one of those pi over 4s. Yeah, it's 3 pi over 4. And where's tangent 1? Well, shoot. Tangent is sine over cosine. And the only reason that I wrote that is to remind you that it's something over something. When is something over something 1? Yeah, when it's the same thing over the same thing. So where does that happen from negative pi over 2 to pi over 2? Yeah, that's right. It happens when it looks like that. Remember? That's the same thing. That's where you get the same thing. And that happens where? Well, it happens at pi over 4. Okay, now we're adequately prepared to actually do math tomorrow. See you then, cheers. Just kidding. To push yourself, do these 3 too. Bring those tomorrow, we'll talk about.